Again, welcome to College Algebra. In these lectures, we're going to discuss about applications of quadratic equations. In our previous lectures, we discussed how to, again, solve quadratic equations using factorization or quadratic formula. Again, this is our Unit 7, lecture part 5. So our main objective, again, is to solve geometric problems using quadratic equation. Also, how to solve uniform motion problems, how to solve falling body problems, and how to solve business problems using, again, quadratic equation, and also how to solve shared work problems. So we're going to start with solving geometric problems. So we have an example here, and our question here said the length of a rectangle exceeds its width by 3 feet. So this means we have a rectangle shape here, and the length is W plus 3. According to the question again, the length exceeds the width by 3. So if the width is W, the length will be W plus 3. Now our question here is to find the dimension of the rectangle. So again, the length of a rectangle exceeds its width by 3 feet. If its area is 40 square feet, we should find the dimensions. So our goal is to know the length and also the width of the rectangle. But again, the area is given to us. So this means we are going to use the area formula. The area of a rectangle will be the length times the width. So it will be W plus 3 times W. So here we say to find an equation that models the problem, let W represent the width of the rectangle. Then W plus 3 will represent its length. Now, since the formula for finding the area of a rectangle is the length times the width, we are going to get W plus 3 times W, which equal to the area. The area is 40 square feet. So we can write the equation as W plus 3 times W equal to 40. Again, the formula to find the area of a rectangle is the length times the width. The question says the width, assuming it's W, and the length exceeds the width by 3. So if the width is W, then the length will be W plus 3. And the area is given to be 40 square feet. So since area equal to length times the width, we get W plus 3 times W, which is the length times the width, equal to 40. Now we are going to open the parentheses. So we get W times W will give us W squared. W times 3 will give us 3W, which equal to 40. So we can see that we have a quadratic equation here now. So we get W squared plus 3W. We bring the 40 from the right side of the equal sign to the left. And since 40 is positive, when you cross the equal sign, it's going to change to negative. So this is, again, a quadratic equation. Now the goal is to find the W. So we can solve this equation by factorizing, because we know to get 40, if we have negative 5 times positive 8, that will give us negative 40. Now the difference of negative 5 and plus 8 will give me positive 3. So the two values will be W minus 5 and W plus 8 equal to 0. Now we take the W minus 5 equal to 0. So the W gives us 5. And we have W plus 8 equal to 0. And the W gives us minus 8. Always quadratic equation, we are going to get two solutions because the exponent, the highest exponent is 2. Now, since this is an application problem and we are finding the dimension of a rectangle, the width cannot be a negative value. So we just ignore W equal to negative 8. The width can be either 0, which means the object doesn't have no width, or a positive value. So we know now the width is 5. So if the width is 5, the length will be 5 plus 3, which will be 8. Based on the question, the length exceed the width by 3. So our final solution again will be, again, the width is 5, and then the length is 8, because W plus 3 will give me 8. Again, -8, we are going to discard it, because again, a measurement cannot be a negative value. So let's move to our next problems. So again, our first question, solving geometric problems. Second question, solving uniform motion problems. So the question given to us here is, we have a man that drives 600 miles to attend a technology conference in Tampa, Florida. On the returning trip, he is able to increase his speed by 10 miles per hour. And also it saved 2 hours of driving time. So a man is traveled 600 miles to attend a technology conference in Tampa, Florida. But on the returning trip, he increases his speed by 10 miles per hour, and that saved him 2 hours of driving time. Now the question is, how fast did he drive in each direction? So now we need to know the direction going to the technology conference. Now increasing by 10 miles per hour, saving 2 hours, again the speed. So here we can say that we can let X, again, you can use any letter. Here we are using S to represent the car's speed, and that's what we are looking for. And speed is always in miles per hour, driven to the conference. So on the returning trip then, the speed will be what? S plus 10, because it's increased by 10 miles per hour. So again, if the speed S represent the time and the speed that the man took to drive to the conference, returning should be S plus 10, because it increased the speed by 10 miles per hour. Now we should know the formula for finding, again, this is a speed and time. So we should know the formula for finding the distance. So distance will be the rate times time, which is the speed times time. So to look for time, it will be distance over the rate, or over the speed. So if we know this formula, then we can write the outbound trip, that's the trip that is taken to the conference. The distance is 600. The speed rate is S. As we said, we should let S assuming the speed, and that's what we are looking for. So if the speed is S, then the time will be the distance over the speed, which is 600 over S. Returning trip also is the same distance, 600, but this time we increase the speed by 10. So the rate will be S plus 10. So the time also will be 600 over the rate, which is S plus 10. Now, although neither the outbound nor the returning travel time is given, we already know the difference of those two times. So I know 600 by S minus 600 by S plus 10, when it's increased, we save 2, so equal to 2 hours. We can see from the question here. Let's go back to the question 1 second. So the question here said, on the returning trip, the man was able to increase his speed by 10 miles per hour and also save 2 hours of driving time. So this tells us that the difference of the speed of going the outbound and the returning trip, the difference of the time is 2. We know time is distance over the rate or the speed. So the outbound time minus the returning time, the difference is 2. So if we can set up this equation, then we can be able to find the S now. So this equation will turn to, again, a quadratic equation. So what we do here, we will find the LCM. We saw 600 times S plus 10 over S times 600. So that's what we have here. multiply both sides by the LCM, S times S plus 10, this side, and on the right side also. Then we open the parentheses, we get 600S plus 10 minus 600 times X, cross multiply. 600 times S plus 10 minus 600 times S. Well, again, when we find the LCM, we solve it. Then 2 will multiply S times S plus 10. Now we can open the parentheses. We get 600S plus 6,000 minus 600S equal to 2S squared plus 20X. So here we get again 6,000. 600S minus 600S will cancel each other. And we get 2S squared plus 20x. We bring everything to the right side. We get 2s squared plus 20x minus 6,000. We divide the whole equation by 2, so we get s squared. 20 divided by 2 give me 10x. 6,000 divided by 2 give me 3,000. Then here also we can factorize, because we know if we have 50 and 60, negative 50 times positive 60 will give me negative 3,000. Then negative 50 plus 60 will give me positive 10. So we can get s minus 50, s plus 60. So our final answer will be s equal to 50 and also s equal to negative 60. But again, we are going to discard negative 60. The speed cannot be negative value. So this is our 50 and this is our negative. The solution s equal to negative 60 must be discarded. The man drove 50 miles per hour to the conference. So the returning trip will be 50 plus 10, which is 60 miles per hour on the returning trip. So the answers are correct, because 600 miles trip at 50 will take 12 hours. And at 60, the same trip will take only 10 hours, which is 2 hours less. So this problem, again, we are using quadratic equation to solve it. But the key here is that, again, here, since we are dealing, from the question, we are dealing with speed, distance, and time. So we have to use the distance formula, which again, the distance is the speed times the time, or rate times the time. So here we were able to find the time using the distance formula for the outbound trip and also returning trip. And since the question said the difference of the two, after it's increasing by 10, is 2. And the difference of the two, I mean the difference of the two speed, the outbound and returning, is 2. So again, we were able to come up with quadratic equation and solve for the S. So let's move to the next example, which is solving falling body problems. So our question here said, if a water balloon launcher propels a water balloon straight up into the air with an initial velocity of 144 feet per second, its height is given by the formula h equal to 144t minus 16t squared, where again h represents its height in feet and t represents the time in seconds since it was launched. Now our question is, how long will it take for the water balloon to return to the point from which it was launched? So the formula is given, the height formula is given to us. We know the initial velocity of 144 feet per second. So we write down the formula. Here we say that when the water balloon returns to its landing point, its height, of course, will be 0. Because when I threw an object from the ground up to the air, and the object fall back to the ground, the height will be 0. There will be no height. If I throw it on the air and it stops somewhere within the air, the height to be from the ground to that hair, or wherever I start to throw it to that hair. So here we know the formula is given to us to be h equal to 144t minus 16t squared. So h represents 0. So here we can find the value of t. We can see that here again we have a quadratic equation. We're able to find a 16t squared 144t. And we find the common value in these two values was 16t. And 16 can go into 144 is 9. The t will cancel, so only 9. Here we have t squared, so we have 1t left. By 16, we go into 16 is 1, so it's 1t, which is the same as t. So our first value will be 16t equal to 0, so t will give us 0. Or 9 minus t equal to 0, and t will give us 9, positive 9. So that's our solution, t equal to 0 and t equal to 9. So now at t equal to 0, the water balloon height is 0 because it was just released. But when t equal to 9, the height is again 0 and the water balloon has returned to its starting point with the time again 9. Okay, so next question is solving business problems. So here we said the bus company shuttles 1120 passengers or 1,120 passengers daily between Rockford, Illinois and O'Hare Airport. Now, the current one-way fare is $10. For each 25-cent increase in the fare, the company predicts that it will lose 48 passengers. What increase in the fare will produce daily revenue of $10,208? So first, let's represent Q as the number of quarters the fare will be increased. Since we say for each 25-cent increase in the fare, the company predicts that it will lose 48 passengers. So then let the new fare will be 10 plus 0.25Q, because we have $10. The current one-way fare is with $10. Now, since the company will lose 48 passengers for each 25-cent increase, we are going to have 48Q. Q represents 25%. Will be lost when the rate increased by Q quarters. Now, they say the passenger load will then be 1120. Remember, 1120 is the total, the bus company shuttle 1120 passengers daily between, so that's total. So it will be 1120 minus 48Q passengers. So if we know this, then we can set up our equation. But since we know the daily revenue of 10,208 will be the product of the rate and then the number of passengers, we are going to have 10 plus 0.25Q times 1120 minus 48Q, all equal to 10,208, because 10,208 is the daily revenue. So we know we charge 10, then additional 0.25Q, quarters Q. Then we have 1120 minus the loss, we lost 48 passengers, so 48Q. So from here, we can open the parentheses. 10 times 1120 will give me 11,200. 10 times 48Q will give me 480Q. 0.25Q times 1120 will give me 280Q. 0.25 times 48 will give me 12. And Q times Q will give me Q squared equal to this. Then we combine the like terms. So we have minus 48Q and plus 280Q. So we get minus 200Q. We have minus 12Q squared. The difference of 11,200 and 10,208 will give me 992. Then we see that we can be able to divide the whole equation by 4. So 4 will go to negative 4. Negative 4 will go to negative 12 will be 3. Negative 4 will go into 200 will be positive 50. Negative 4 and 992 will give me now positive and negative. So I'll get negative. And 4 can go into 992 to be 248. So from here, we can solve the equation using quadratic formula. So quadratic formula, as we said in our previous lectures, is minus b plus or minus square root of b squared minus 4ac over 2a. Now, when we go back to the equation, a will be 3, b will be 50, and c will be minus 248. So we plug in the value minus 50 plus or minus 50 squared minus 4 times 3 times negative 248 over 2 times 3. We solve this question using, again, calculator. We get minus 50 plus or minus square root of 5476 over 6. We can find the square root of 5476, that gives us 74. Now we have a minus 50, other plus or minus 74. So first, minus 50 plus 74 over 60, my final answer will be 4. Now minus 50 minus 74, my final answer will be minus 62 by 3. Now, since the number of riders, the answer can never be negative. So since the number of riders cannot be negative, the result of minus 62 by 3 must be discarded. Now, to generate 10,208 in daily revenue, the company should raise the fare by 4 quarters, or $1 to $11. So our final application problem will be solving the shear work problems. Yeah, the question here said again, we have one environmental company can clean up an oil spill in 2 days, less time than its competitors. Working together, they were able to clean up the spill in 10 days. How long will it have taken the first company to clean up the spill if it worked alone? Here you can see that they work together and they were able to finish 10 days. Now here we say, suppose the first company can clean up the spills in X days, then the first company can do in 1 by X of the job each day. Because the first company can do the work in 2 days less than its competitor, it will take the competitor S plus 2 days to clean up the spill. And also the competitor can do 1 by S plus 2 of the job each day. So if that's the case, we can form our quadratic equation here. Now, working together, they can clean up the spill in 10 days. So together, they can do 1 by 10 of a job each day. Now, the sum of work each can do in 1 day is equal to the work that they can do together in 1 day. So we have 1 over X plus 1 over S plus 2 equal to 1/10. Since together, they do 1/10 of the job each day. So here we can solve this equation. We get our LCM, solve it, and this is what we get at the end. We get x squared minus 18x minus 20. Again, I skip all this step because we cover quadratic equation already and also how to solve irrational expressions. So if I have this problem, first I will look, okay, can I get two numbers that when I multiply, I'll get minus 20. When I combine, I'll get minus 18. And then that can give us, again, we can do it, but the best way, we use the quadratic formula. Using the quadratic formula means A is 1, B is negative 18, C is negative 20. So we get negative 18 for B, plus or minus square root, B again, negative 18 squared times 4 times 1, C is negative 20 over 2. Now, if you do your calculations with your calculator, this is what we get finally. So we get two answers. One is 18 plus and one is 18 minus the value. So we get 19.05 and also negative 1.0. Now, here is about working. So since the work cannot be complete in a negative number of days, we discard the solution of negative 1.05. So technically to be 19 days, or let's say roughly 20 days to do the work alone. So this will be the conclusion of our topic here. Again, this topic is more or less like a review of quadratic equation. In our previous lectures, we went through quadratic equation how to solve it either by factorization or by using quadratic formula. Now, if you need a review of that, you can go through that before these lectures. These lectures teach us how we can solve a problem using quadratic equation. So it's more or less applications, solving application problem using quadratic equation. We saw the geometric problem whereby we are finding the length of an object, in this case rectangle. We also saw a business problem, etc. So again, wish everybody the best and thank you for your time.